Hello, third graders. Today we are going to be learning our fourth geometry lesson, and we're going to take everything we've learned to compare and contrast quadrilaterals based on their attributes. So you remember from ELA that compare and contrast means to talk about the way things are alike and to talk about the way they are different. So we will be doing that with quadrilaterals, but we will be using geometric vocabulary in order to describe the ways they are alike and describe the ways they are different. So let's review some of that geometric vocabulary. Polygon is a closed shape with three or more straight sides and three or more angles. A side is any line segment with two endpoints that's used to form a polygon. So if you look at this red rectangle here, these are the sides. Now, where the sides come together is called a corner or a vertex. It's this point right here where the two sides meet. The inside of that corner, which is formed when these two sides meet, the inside of it is called an angle. And we talked about a special kind of angle called a right angle. A right angle is an angle of 90 degrees, and it's the perfect square corner, a corner of a square. So these lines make a perfect square corner, like the corner of a piece of paper, the corner of a book, the corner of a desk. Most of those things are right angles. And then the last phrase that we need to know is parallel sides. Parallel sides are sides that are always the same distance apart. If they were to continue on and on forever and ever, they would never cross. So this red rectangle here has two pairs of parallel sides. The top side is parallel to the bottom side. If you were to continue these lines on and on and on and on, they would never cross. And these two sides here on the left and the right are also parallel. They're the same distance apart forever and ever. Now let's apply these terms to the special types of quadrilaterals we've learned about. Now, of course, a quadrilateral is a polygon with four straight sides. One type is a square. A square is a parallelogram, and anything that says parallelogram, as you learned yesterday, means that it has two pairs of parallel sides. So a square is one type of parallelogram. A square also has four sides that are all equal lengths. They're all the same size, same length, and it has four right angles. Right there, right there, right there, and right there. Now a rectangle is also a parallelogram, has two pairs of parallel sides. The opposite sides are equal length. So the top and bottom, they're the same length. The sides, they're the same length. And it also has four right angles. The difference between a rectangle and a square is a rectangle doesn't have all four sides equal length. Rhombus is our third type. It is also a parallelogram. It has two pairs of parallel sides. And a rhombus has four sides that are all the same length, just like a square. What makes a rhombus a little bit different is it does not have four right angles. And then last is a trapezoid, and a trapezoid is not a parallelogram. It is not because it only has one pair of parallel sides. So, reviewing yesterday's learning, parallelograms are four-sided shapes that have two pairs of parallel sides. And we just read together that a square, a rectangle, and a rhombus are all categories of parallelograms. So what's a parallelogram? Well, it's quadrilaterals. Means it has four sides. Opposite sides are parallel, meaning they're always the same distance apart. It has two pairs of parallel sides, and the opposite sides are equal. So down here, these are examples of parallelograms. These all have two pairs of parallel sides. These are not parallelograms. The red and the blue are not parallelograms because they only have one pair of parallel sides, which means they are trapezoids. And then this guy here is not a parallelogram because that's a triangle. So it doesn't even belong in the quadrilateral category. Okay, so let's begin to compare and contrast some shapes using this fun little Venn diagram. You hopefully have used Venn diagrams before. It's a way that we show the way ways things are alike and ways things are different. So in this Venn diagram, this circle here represents shapes where all sides are equal lengths. This circle represents shapes that have two pairs of parallel sides. And then where they intersect here are shapes that belong to both categories. So E has two pairs of parallel sides, but it does not have all four sides equal length. So it belongs over here. Same with B. Whereas A, C, and F, they have all sides equal length, and they have two pairs of parallel sides, and that's why they go here in the middle. I'm going to sort them a little neater. All right, now A, B, C, D, E, F. Let's look at G and H. I know they made copies of them. So G, where would that one go? Does G have all sides equal length? Nope. Does it have two pairs of parallel sides? No, it actually does not. It looks like it might, but it doesn't. If you were to take a ruler and keep drawing, these sides would eventually cross. So this one actually goes nowhere. We're going to put them right there. And then how about H? Does H have all four sides equal length? Nope. Does it have two pairs of parallel sides? Nope, only one pair. So it also does not belong in the Venn diagram anywhere. So think about what you know. What do we call shapes that are here in the middle? They have all sides equal length, and they have two pairs of parallel sides. And before you say square, because yes, A is a square and C appears to be as well, remember a square has to have four right angles. This one does not have four right angles. So what would we call these? They are rhombuses or rhombi, which means that they have two pairs of parallel sides and two pairs of parallel sides. Yes, for a second that sounded wrong. And four equal sides, or all sides equal length. Nice work. Okay, so now that we get to the meat of our lesson, comparing quadrilaterals, I want you to really think about that geometric vocabulary. Okay. Also, I did add color to them to make them be a little more fun to look at, but we're not going to use color as a way of comparing them. So yes, this one's blue, this one's a little more of a purpley color. We're not going to use those descriptors to compare and contrast. So here's a little thinking guide for you. Think to yourself about each of these two shapes. How many sides does the shape have? How many pairs of parallel sides do the shapes have? Are they parallelograms? How many right angles do the shapes have? Are any of the side lengths the same? And are all of the side lengths the same? Okay, so now let's look at these two. How many sides does the shape have? Well, they both have four sides. So the trapezoid and rhombus are both quadrilaterals. That's a typo, it should say are, which means they're four-sided closed shapes. Let's see, both the trapezoid and the rhombus have at least one pair of parallel sides. The trapezoid has a pair right here, and the rhombus actually has two pairs, so they both have at least one pair. Neither of the shapes has any right angles. Now, how are they different? The rhombus is a parallelogram and the trapezoid is not. So the rhombus has two pairs of parallel sides, but the trapezoid does not. Also, the rhombus has all equal side lengths, and the trapezoid does not. Okay, let's try one again. Let's use math language and geometric terms to explain how these two polygons are alike and how they are different. I'm actually going to take the shade. Hopefully you didn't memorize that already because I don't want you to look at the answers yet. All right, here we go. So look at the square, look at the rectangle, and think to yourself, how many sides does each shape have? How many pairs of parallel sides do the shape have? Are they parallelograms? How many right angles do the shapes have? Are there any side lengths the same? And are all of the side lengths the same? I'd like you to take a moment, pause if you'd like, to look at those two shapes and think of at least two ways they are alike and at least two ways they are different. Okay, let's see what we've got here. So how are they alike? Well, squares and rectangles are both quadrilaterals. They both have four sides. Both squares and rectangles have two pairs of parallel sides, so they're both parallelograms. And both squares and rectangles have four right angles. Okay, let's see. How could they be different? The square has four equal side lengths. The rectangle does not have four equal side lengths. Only the opposite parallel sides are equal. Okay, nice work. So here is your assignment for today, and I apologize for this being kind of smacked here in the middle. It's the best way to make it fit. This is page 7, front and back in your packet, or it might be in your teacher's Google Classroom. Just read their directions and see what they want you to do. You're going to use math, language, and geometric terms to explain how the two polygons are alike and how they are different. And I put the questions here to help you. You want to ask yourself things like, how many sides does each shape have? How many pairs of parallel sides do the shapes have? Are they parallelograms? How many right angles do the shapes have? Are any sides the same length or are all of the sides the same length? Now for the rhombus and the square, part of it has already been done for you. They gave you lots of ways that they are alike. Let's look at a few of them. A rhombus and a square both have 4 sides and they both have 4 angles. A rhombus and a square both have 4 equal side lengths. Both of them are parallelograms with 2 pairs of parallel sides. Both are polygons and both are quadrilaterals with 4 sides. So how are they different? Let's look at that third question. How many right angles do the shapes have? How many right angles does the rhombus have? Hopefully you said 0. And how many right angles does a square have? It has 4. So if you were going to write how they are different, you could say a rhombus does not have any right angles, and a square has 4 right angles. See if you can come up with any other ways that they are different. And then the back of that page, you're going to do the same thing, but with a rectangle and a trapezoid. All right, thank you for listening. Good job today, and I will see you next time.